Okay, so the mean value theorem for intervals, right, this is the formal definition. Okay, we're going to be using a lot with this. Now, to kind of understand what they're talking about, that there's some kind of number C in the closed interval that makes sense, what the mean value theorem kind of says deals with like the area underneath the curve. So if I give you guys just like a picture here, right, we have some curve F, right, and we're given this over the interval AB. So I'm just going to close this. Right, here's the A, here's the B. What the mean value theorem states is that if you calculated the area under the curve by, you know how we've been doing our definite intervals, find the area, we take the integration, antiderivative of this, we plug the B in minus whatever the A is when it's plugged in. They're saying that if you took the area under a curve by using integration, it's going to be the same thing as if I take f of C times B minus A. So there's a way for us to figure out some value of C, right? So if you went over and you found a value of C somewhere in here, draw a line up, where you can make a rectangle at this point, like it's a special point that will create a rectangle in here, so that if you calculated the area of this rectangle in green, it would be the same as if I calculated the area of all the blue stuff, the area under the whole blue. See how part of it's displaced up here?
I know what you're saying.
Okay, so the C part actually will tell you guys, I guess the C kind of shows you where on the x-axis you'd have to go between the interval A and B to get f of C. Isn't f of C, like if this is like the x, this would be like the y kind of deal? So f of C tells you the height that you have to make the rectangle to actually calculate what the area under the curve would be. Right, they'd be equal. I thought this was kind of cool. You can think about it like this. Area of a rectangle is the length times width, right? That's area of a rectangle. Well, the length of this whole thing, think about the whole thing, is B minus A, so that distance, and the height, f of C, right, is going to be like, well, the height part.
This makes perfect sense.
It kind of makes, and again, this, if you look in your book, you might be like, what the heck, why is this even, I don't understand what it shows. Even some of the videos are really complicated with what this theorem shows. But all it shows you guys is that, yeah, I could take the area under a curve now by using integration, which is, that's what you guys have been doing. But there's another way to do it, dealing with this mean value theorem, that if I could find a value of C, right, once you know C, we could figure out the actual area and they should be equal. Okay, we're going to do that. We're going to have to find the C. All right. Maybe I won't show you guys the video. I don't know. This is that stuff. Okay, so, do you like videos? Do you want to watch a video of it? It's up to you. We can watch. Oh, actually, let's not watch one because we're really low on time here today. Yeah. Okay, so let's say, I'll use the example though that they did in here. I thought the example was pretty good. Here. I just want to do the actual.
It makes so much sense.
It actually does make sense, right? All right, that's what I want. 2 over 4. Right. So I will give you guys your mean value theorem formula, what this actually is, so it kind of helps you, especially when we're going through. Let's get a little bit of this. Let's bring it to the other side. Sorry, I'm a little unorganized today. Okay, there we go. All right. Okay, so your first thing that you guys want to do is to find C, right? What we need to calculate first is this side right here. Okay, so how would you guys go about calculating this? What would you have to do? So it's not derivative. Integral of 16 over x squared. Yep, whatever the f of x is. Now, how can you guys write your interval?
16x to the negative 7.
4 over 2.
4 over 2. Good. Make sure the bigger one's on top. Perfect. All right. And make sure we have our dx because we're going to take the integral with respect to x. Now, this is going to be our first thing. We need to figure this out first so we can find the value of c that will make this true. All right. Well, if you guys want to start this thing, and you're good at integrating and actually doing all this stuff now, and plugging numbers in, so go for the gold. If you want to go on your own, and make sure you remember to bring this up. So add 1 to the exponent. So we should have 16. And then go ahead and calculate it out. You guys want to get calculators? They're right in my desk drawer, so feel free. Oh yeah, so you made this like 4?
Yeah.
Yep.
No, I mean a negative 16 over x.
Yeah.
Yeah. Yeah, that's fine. That's totally fine. Yep, as long as you do it after you did your integration. Yep, yep. Totally okay. Yeah, even if you wanted to do it like that's why you move it down now, you would get 16 over negative 1 times a positive 4, which will be a 16 over negative 4, which will be negative 4.
Yeah, so same thing.
Yep, same thing, right? Okay. Yep. Same thing here. It just kind of helps if you don't have a calculator. What are you gonna do? So it's negative 8 with I think it's gonna be plus 8, right?
Yeah.
Yeah.
Well, it'll turn out, yeah.
Yeah, it turns into
I
12.
just didn't write the plus yet.
All right, did you guys get 4?
Yeah.
Yeah, yeah. Okay. So, guys, this 4 represents this whole part right here. You know that this right here is 4. Okay? Now, to get the other side of this, Kyle,
Yes.
okay, so we have our 4 represents the left side. That needs to be the same thing as f of c times b minus a. So when you guys look at your f of c, the f of c is like the normal function, like what you originally had, like way up in the very first thing. But if you have f of c, what is the f like? All right, wait, sorry, I said that wrong thing. What would you put the c in for? X, good. Right? If it's like f of x, you want f of c, it means the c is like the x. So we're going to find out. Okay. So it's going to
16 over like c squared?
yes, Kelly, exactly right.
Oh.
Good job. Now the b minus a, you guys are just taking from your interval. Yep. So b minus a, 4 minus 2, b minus a would give you guys 2. So we're going to have to take this and times it by
Are we like solving for c?
yeah. So once you guys have this set up, right, we're solving for c. It becomes an equation. So 16 times 2, so we get 32 squared 4. So here you're just solving for c. You're going to figure out how to do this. So
4
I got it.
c squared equals 32.
good. 4c squared 32 divided by 4. And then just watch out for this part, guys. When you guys are here to get rid of your squared, make sure we do plus or minus right in front. Now when you have even exponents, right? When it's even, you have to do the plus or minus. Odds, we don't have to. Okay. So when you have even exponents, we get rid of them. You have to do the plus or minus. When it's odds, you don't have to do that.
Yeah, like if it was c to the third,
You want to plus or minus, you just cube it through. If it's like a fifth root, you just take the fifth root. But if it was like a fourth root, you still have your plus or minus. Right, it's because it's, I can explain this in a second. Cube it. Yeah, that's fine. Okay. All right, so in here, guys, Kyle, drive me nuts today. You're so loud. Okay, so what we need to do is figure out what does this equal. Who's got a calculator? Kaylee? Good. Can you do positive radical 8? Brian, you got a calculator? Do negative rep, please. Go for it. See what you would get.
I got 2.8.
You got 2.8? Right. All right, and then we have two possible values here. Now, when you guys are looking at this, the value of C that's going to work, okay, look to see what your interval is, right? This is where we could get tricked. Because you have two values, right? You only want to choose the one that's going to fit in the interval that you have. So does the negative 2.8 work?
No.
No, it's not in the interval, right? So this one can't go. Your value of C that'll make this true is going to be 2.8. Right? So that means if you guys really wanted to figure out, if you drew this whole thing out, we'd have to go over 2.8 on the x-axis. Think about what f of 2.8 would be, and then that height up to make a rectangle. Just says that this value will make our two areas the same. When you guys are dealing with theorems, it's kind of just proving it. You're not really like,
I'm confused.
you're not really actually showing that the two areas are equal. It's just saying that if I want to show that this theorem works, right, the value of C that I would need would be 2.8. So you guys are going to be finding a lot of things with values of C. Now let me give you another one of these. Why don't you guys try this one? See if you can get it, the value of C. Sorry. Use this as kind of like a guide to what you need, like your steps. You know what I mean? Go through, make sure you do your integration first, kind of rewrite everything.
Holy crap, that's a giant.
Now it's just the court. You want to give you
Correct. Isn't it the root of 9 over
you want me
x?
to take things up? Negative 3. And one is negative 2 or negative 2.
I'm not there yet.
I just, for some reason I saw it as
First one was 12.
Did you record it?
Did I do that
Good
right?
job.
Okay, good.
Yep, now you can go
I
like,
always forget to
go
do
top
first
and
and
bottom
first.
first. Top first. Four. Yeah, sorry, we have that four. Did you get negative one? Oh. So this is going to be negative 4.5, or 2.5, and that's what we're looking for. Do it out. What do you get when you do that? Wait, when you do the negative though? We should have a positive 4.
4.
Oh, what's your? Your value of 4 should be positive 4. This right here, this is up in there. Okay, so
cubic root of 9.
2 down here. Okay, so we bring this up.
Cubic root of 9. Yeah.
Oh, negative 3, right? Now we integrate this to 9x to the negative 2 over negative 2.
Oh, okay.
That's the bottom part. That's right here.
So I made the one. That's 1.65.
Yeah, nice. Totally right. Good job.
So I got, yeah, I was close to
I got that.
so I got the one.
Guys, in order for the first part, for your integration, when you're actually doing the integration steps, you should have 4. Right, you should get 4.
Yeah, I did 4.5.
Oh, that's right.
You're both positive.
Oh, 1.7. 1.65, right?
And then you're going to do the 4 minus Wait, you just started there. This is good.
Yeah, well, no, yeah, that's, I got it.
You got it right now. Okay, good. Nate, you were good? Okay, awesome. All right, 250 is 1.65. Awesome. All right, so we're not going to do too much with this. It's not like that important. More that those of you guys going on to Cal 2, you have at least, you could say, I've seen the mean, value theorem for integration before. What? Yeah, you have one. It's like one question. I'm going to do one. Just one so you practice it. Okay. Oh my gosh, hang on. Let's do page, yeah, what did I mark? Let's try. Let's try 45. How about right there? So you guys have one question?
It was mistyping. She'll call you back later.
All right. So just number 45, okay?
Can I get the reference?
Yeah, if you guys just want to write it down or take a picture and send it to each other, do you want to print it up here? Yeah, here. Yeah, just 45.
Oh, no. My notebook is empty.
Okay, so here's 45, guys. That's what it asks you guys to do.
And it's full, not empty, it's full.
Yep, it's easy. I just want you to just get a practice by yourselves. You don't have to sit down and have to do something. Or just one. Just make sure you can do it. This is a very long section. We have like 3 more things in this one little section. So. Yeah, I know you guys can use maybe substitution.
Is it hard?
Maybe, I don't know. I'll see if I can start it Friday.
I should probably try it.
Okay, Friday I'll know for sure.
I don't know how
Got it.
because I have class with on Monday, which I really skipped. So
watch it. If it's use substitution, you might want to be careful because it's a very important concept for calculus. Like super important.
Okay, thanks.
Yeah, no problem. Like I said, I remember it's one of the things I know you guys are gonna need. So. Anybody need help with anything? Quiet today, tired?
Yeah. Thank God. That's probably why I understood it. No, I'm sorry, you're not talking. See you later. Bye. Have a good day.
I always do the minus one for adding one. It's like the last one.
Oh, it's tricky when you're dealing with the negatives and I don't know.